XK, you may begin.
Good morning, grade 9s. I'm back again. Thanks God, it is Friday. It's a fake Friday today. We'll see each other next week, Monday. But as I promised yesterday, that today we're gonna do whatever that you guys had asked me. Thank you so much for those who did direct message me on Twitter at MbataX and on Instagram at XKIM what they wanted us to do. So today, guys, it is solely made up of what you asked me to do today. It's not my lesson, but it's the lesson that you guys controlled. Thank you very much for always touching base with me. I really, really do appreciate. I am Kolisani Mbata. We are in grade 9, Natural Sciences. By the end of today's lesson, we would have obviously done a revision on this. At the end of the lesson, you will know how we'll revise the periodic table, representing elements, classification of elements, compounds, balancing compounds, chemical equations, atomic molecules, and obviously, as I've mentioned, that today it is your long weekend, starting from tomorrow morning. So I've prepared a long weekend homework. Grade 9s, this is going to be a very much interactive lesson. I'm not going to do things alone because I've taught most of this session with you. So we will work together. Yesterday, I gave you a homework. Let us do the correct the corrections now. For your homework corrections, you are supposed to give a correct they said to you give a correct scientific term. Give the correct scientific term for each of the following descriptions. What do we call an arrangement of elements in a organized pattern? So is the periodic table. Is the periodic table. Did you all get that? Or you didn't do the homework? Or you forgot your books at home? What happened? So the correct term there is an arrangement of elements in an organized pattern. We call it the periodic table. A metal with protons in the nucleus is supposed to be with the correct answer is manganese here, the proton with the 25. I think it was 25 here. With 25 protons. And then the correct answer is manganese. Remember, manganese. The spelling, is it correct? No. Manganese. I'm hoping we are all doing corrections now. Then they say examples include sodium, potassium, and iron, also carbon. So the correct answer here is we're talking about diatomic molecules. Diatomic molecules. Remember, we're doing diatomic molecules. Those are the examples of diatomic molecules. So you just write diatomic molecules. The classification of ion. What is an ion? So the classification of ion is a metal. Metal. Remember, when you're looking at your periodic table, you know that ion is a metal. So whenever ion reacts with oxygen, we are going to get iron oxide. A non-metal found in all living things. What is a non-metal that is found in all living things? It is in all living things. So the key word there is living things. So we're gonna say it's oxygen. Oxygen. I hope I'm not moving too fast, grade 9s. Any questions? Grade 9s, any questions? I'm looking for any hands up, any questions. You can type on your chat box there if you've got any questions concerning the first part of our homework. There are no questions. I'm moving on. Can I move on, grade 9s? They said give the correct scientific term for each of the following descriptions: an arrangement of elements in an organized pattern, periodic table. A metal with 25 protons in the nucleus, manganese. Examples include sodium, potassium, and iron. Also carbon, it's diatomic molecules. The classification of iron is a metal. And then we've got a non-metal found in all living things. Go to your periodic table, you will see that oxygen is a non-metal. Number 2, use your periodic table to answer the following questions. They said to you, name the noble gas in period 2. A noble gas in period 2, what is it? A noble gas is going to be, neon. Where am I? Neon gas. That is a noble gas that is found in period 2, grade 9s, I'm sorry. They say to you, what element has 86 protons in its nucleus? So it's radon. Radon from your periodic table, grade 9s. All these answers, we take them from the periodic table. Remember yesterday I explained to you, I said, make sure that the periodic table becomes your best friend. We are doing corrections from yesterday's homework. So they say, name the element with the symbol Sn. So the symbol Sn is tin. Tin. If you don't know how to read your periodic table, you will not get these answers, grade 9s. Describe 2 properties of chlorine. What are properties of chlorine? Grade 9. So the property number 1 of chlorine, it is a disinfectant. Disinfectant. And it is also chlorine. It is a disinfectant, and it is also I'm trying to check on a non-metal. And it is a non-metal. Any questions, grade 9s? I'm waiting for questions, grade 9. How many groups are there in the periodic table? How many groups are there in the periodic table? So we definitely have 18 groups. We have 18 groups. Nothing new, it's everything that we've been doing, grade 9s. We've got 18 groups. So I'm saying to you now, any questions before we start with today's lesson? Any questions? Any questions, grade 9? Hands up? No hands up. No any questions? No questions. I can continue with today's lesson. Thank you very much, grade 9s. Let us look at the periodic table again, grade 9s. Remember that chemistry is made up of periodic table. All our reactions are from the periodic table. All the elements are found in the periodic table. So we say that in the periodic table, it has 114 known elements, and they're listed there in the periodic table. Elements are different, but sometimes they can behave in similar ways. So now, even though elements, they can be different, but they can have the same behavior. Like we have people who are different, but they behave in the same manner. So are the elements. The elements are different, but they can behave in the same manner. Remember that we have different groups and different periods. So those are also things that determine them the behavior of elements. We said that representing elements in the periodic table will be a symbol. A symbol in an element in a periodic table will tell us the name of the element. And again, the element, they are in blocks there in your periodic table. So in your box, you'll find a chemical symbol, you'll find a small number, which is an atomic number, and then you'll find the bigger number, which is a mass number. Are we clear, grade nines? You've got a block. In a block, you find a symbol. And then after a symbol, you find a small number there, which is written, which is an atomic number. The bigger number in there is a mass number. So there's a difference between an atomic number and a mass number when you are looking at your periodic table. Elements in the periodic table are arranged in groups and in periods. So the groups are vertical columns, and we've got them. We've got 1 to 18 groups. You've got 1 to 18. So those are your groups. They are vertical. That means they are running from up to the bottom, up to the bottom. So you've got 18 groups there, and you'll always find your hydrogen in group 1. Are we clear, grade nines? Then you've got periods. Periods are rows that run from left to right. So the ones that are running from left to right, we say are periods. From up to the bottom, it's those are your groups. Groups up to the bottom, and there are 18, and then we only have few periods, which are 7. We've got 7 periods, and they are running from left to right. Are we clear? The atomic number of elements, increase by 1. So you just add 1 as you go from left to right. So the atomic number increases from left to right. It depending on the period. Are we clear? Are we clear, grade nines? Then we have 3 groups in the periodic table. These are groups when, remember, don't confuse periods, groups, and these types of grouping. Here we have 3. It's metals, which they form the most part of the periodic table. And then we've got non-metals, which obviously they are the second main ones. And then the least in the periodic table, you will be your semi-metals. So the semi-metals have both characteristics of metals and non-metals. I hope I'm not too fast, grade nines. I hope you are following. I hope you are following now. We are recapping. It is important. Next week, we're starting a new chapter. So we are moving with chemistry. So if you do not understand anything with chemistry, please stop me. Stop me and say, Mr. Mbata, I'm not following you here. And then I will explain to you. So from those elements that we've spoken about that we get from the periodic table, we get compounds. So remember that element and element, they react together to give us a compound. So compounds are made of elements that are joined together. We use symbols of elements to write the formulae for compounds. So those symbols that we get from the periodic table, when we react them together, and then we'll get a compound. Then now, for example, looking at here, we've got H2 and O2 giving us H2O. Then those are elements. Element hydrogen reacted with element oxygen to give us a water molecule here, which is H2O. Are we clear? So the definition of compounds, they say to you compounds are pure substances. Compounds are pure substances. So they formed by a chemical reaction between 2 or more different elements. As I've explained to you, that we get to have hydrogen reacting with oxygen, and then we're getting H2O. One will ask, why do we have these 2 here? These 2 there. Why do we have it? Do we have it there because that is a diatomic element. That is a diatomic element. So we call these 2 a subscript. It's called a subscript. A subscript is this 2 here for the diatomic molecules. Then now, remember, we've dealt with this work. We said we do not just leave an equation without being balanced. One asked me yesterday and said, Mr. Mbata, how do we balance the equations? So look at this one, the one where my cursor is. So now you would see that we've got 2 hydrogens here because it's a diatomic molecule, and we also have 2 oxygens here. But on the right here, we get to have 2 hydrogens and 1 oxygen. Therefore, our equation is not balanced. And then we come and put the coefficient 2 here, which is now we're going to have 4 hydrogens. And then on the left, we have 4 hydrogens, and then we have 2 oxygens. And then on the right here, our compound, now we put the coefficient 2. And then when you're looking at the coefficient 2 there, the coefficient 2, you would see that now, let me change the colors of the coefficients. Then now the coefficients, we add them to add the molecules now in the thingy in our reaction so that they are balanced. You will see that on the right here, the red 2 by this 2 is 4, and then this 2 by oxygen, it's 2. And then comes to check your oxygen on the left, we have 2 oxygen. So our oxygens are balancing both sides. And then again, this red 2 and 2 here, we're getting what? We get 4 hydrogen atoms. And then we can conclude and say our equation is now balanced. Are we clear, grade 9s? Are we clear? I'm sure those of you who were asking, how do we balance the equations, are seeing the light now. Are seeing the light. Do I have someone raising up a hand? Yes, you can ask a question. You can ask a question, Jesse. Jess, your hand is up. You can ask a question. Jesse, I'm waiting for the question. Ngubane also wants to ask a question. I don't know. I'm sure my producer is going to actually get those questions and she is going to forward them. Yes?
Sir, I still do not understand where the 2 that is highlighted in red comes from.
Okay, very much well. Okay, let's look at this. You see where my cursor is, right?
Yes, sir.
It's at 2, the first equation there. You've got H2 reacting with oxygen, giving us H2O. And
yes,
then
sir.
now, what I'm saying to you, we need to balance the equation. Why do we need to balance the equation? Remember, in mathematics, what you do on the left must be done on the right.
Done on the right.
Here in the chemistry, the reactants must be equal to your product, which is your compound on the right. You cannot have 2 hydrogens on the left and then on the right you have 1. If you've got 2 hydrogens on the left, there must be also 2 hydrogens on the right. That's why we balance the equation. So now what do we do? Remember that hydrogen and oxygen, they are diatomic molecules. That's why we've got the subscript 2 here. So if we've got this subscript 2, then, but now remember that water is formed by 2 hydrogen atoms with bonded together with 1 oxygen.
Yes, sir.
So now these 2, the red 2 that you want to know about, we add the atoms. So when we're adding the atoms, we put them in front of the element that we are adding to. Because now this side, we had, remember that we're not going to introduce any elements now in this equation. So our equation needs to balance like this. So what happens is that we've got 2 H2O. I said to you, you need to first look at the oxygen. How are the oxygen balancing in the equation? No, they are not. Why? Because we've got 1 oxygen on the right and 2 oxygens on the left. So first we put 2 here in front of the compound because this is 1. Whatever comes to the right now, H2O is 1. It's a compound. So we add 2 there. We put 2 there, which is 2 multiplied by 2. The subscript 2 here of hydrogen will give us 4 hydrogens. 2 multiplied by oxygen here. How many oxygens are we going to have now?
You're going to have 2.
Yes. Then now that means our oxygens are balancing. We've got 2 on the right and 2 on the left. Then we say, okay, but now without this red 2, we now have 2 hydrogens only. That's why we reintroduce another 2 here to say we want to have 4 hydrogens on the left and 4 hydrogens on the right. 2 oxygens on the left, 2 oxygens on the right. Are you following?
Yes, I'm following now.
Okay, let us move on. You will see as we continue, we're still going to do some more balancing and then you'll understand some more. Thank you so much for your question. I hope it enlightened others as well. So grade 9, let us continue. Then we say compounds get their names from the elements that they are made of. We use the name of the elements to develop the names of the compound. This is very straightforward. You understand it. So these are the names of steps for naming your compounds grade 9. Please take a look at them, follow them. You will never name any compound wrong. Number 1, you identify the elements in the compound. You write down the name of the metal first. You already know which elements are metals, right? So now if you see this is a metal, you write the name of the metal first. For example, if the compound contains only 2 elements, name the second and change the ending to IDE. It's IDE. If the compound contains 3 elements, one of which is oxygen, name the element that is not oxygen and change the ending to ATE. So now we never name the oxygen first. Are we clear? Chemical equations. So now we are going to deal with more balancing. Chemical equations to represent reactions. Chemical reactions, a chemical process in which 2 or more substances react to form new substances. Use symbols. You see, I even wrote in capital letters here. I wrote in capital letters that you need to use symbols to represent reactions. Even if the examiner gives you in word equation, you need to convert it into symbol. Then you will be able to work. Use your knowledge about symbols to represent chemical reactions. I told you that if you want to be a chemist, you want to be a doctor, you want to be a nurse, you want to be a biotechnologist, you want to be anything, you will have to actually make friends with your periodic table, because those elements you'll work with until you finish your varsity. Then we've done this with Jesse. We did this. Everyone understood. This is called a chemical reaction. Hydrogen reacts with oxygen to form water. That was your word equation. Hydrogen reacts with oxygen to form water. So now you know hydrogen is a diatomic molecule. You will say H2 reacting. We're not saying plus, but that positive sign there, we say it's reacting with oxygen to form H2O. Are we clear? We say hydrogen reacts with oxygen to give us water. Then we have done how we're balancing this equation. You know now where is this coefficient 2 coming from. And we said this is a coefficient 2, and then these ones are subscript 2. These are subscript 2. So subscript number in each formula indicate the number of atoms of an element in that compound. So we said we've got 7 diatomic molecules. Remember, we said we have 7 diatomic molecules. I even gave you a sentence that you will never forget. Remember the sentence? The coefficient in front of the formula indicate the ratio in which the molecules react. Here, Jesse, you see? Let me highlight this. Where is that 2 coming from? You know now where is that 2 coming from. You know now. That is the coefficient. So it indicates the ratio in which the molecules react. That's why we say we need to have equal on both sides. Remember, the input must give us the same output. We cannot have the less input and have more output. We need to have a balanced chemical equation. There we go, diatomic molecules. So a molecule composed of only 2 atoms. The diatomic molecules have, this is the sentence that I was talking about, grade 9s. Don't ever forget the sentence. When they're asking you the examples of diatomic atomic molecules, you say, have no fear of ice cold beer. Have no fear of ice cold beer. Just don't drink it. But you mustn't be scared of it. Don't drink it. Have no fear of ice cold beer, grade 9. Have, which is hydrogen. No, which is nitrogen. Fear, which is fluorine. Of, it's oxygen. Ice, it's iodine. Cold, it's carbon. Beer, it's bromine. We are done. Those are your what you call, those are your diatomic molecules from the periodic table, guys. Those are elements which we say they are diatomic. Are we clear? We represent them like this. We say I2F2, I2F2, N2, O2. Those twos we say they are subscript 2. Subscript 2. So you know now. That's why when they gave you those elements in yesterday's homework, you just knew, oh, these are my diatomic molecules. Then atoms are conserved during the reaction, grade 9. So they are not wasted, right? We do not lose atoms during the reaction. We do not lose or we do not gain, but they are conserved. Are we clear? That's why we can now add the coefficients to balance, but our atoms are always kept the same during the reaction, throughout the reaction. The original atoms in the reactants are simply rearranged to form new groups of atoms in the product. Remember that now when the elements, for example, when hydrogen is a gas and is also reacting with oxygen, which is a gas, they are now going to give us a new product, which is a liquid, water. So what's happening to the atoms? They are getting rearranged. Are we clear, grade 9s? Thank you very much. Let us see how do we balance the equations, grade 9, because this seems to be stressing a whole lot of you guys. So when we write a chemical equation, we have to balance it. There is no two way about it. When you're writing a chemical equation, just have at the end, you must balance it. The total number and types of atoms in the reactants is the same as in the product. As I said to you, what you put in, which are your reactants, must be equal to your product, regardless of the name of the product, but they must be equal. Are we clear on that one? This means that there must be the same number of atoms of each type of either side, on either side of the arrow in your chemical equation. There's no two way about it. Follow these steps to balance a chemical equation and you will never go wrong. Example, hydrogen and oxygen, water. Step 1, write down and formulate for all the substances. You've got H2. You've got H2 here. Are you following, grade 9? Someone is breathing heavily. What's wrong? Is that stressing you? I'm here, I'm working with you, grade 9s. I want us to look at those steps clearly. So we've got that. And then step 2, you have to, they give you hydrogen with water, with oxygen to give water. I told you, step 1, you have to write them in a symbol form and in a formula way. H2 reacts with oxygen to give water. Step 2, count the atoms of one of the elements on either side of the arrow. So you're looking at this equation again. So now you said, okay, this side we've got 2 oxygens and this side we've got 1 oxygen. We've got 2 hydrogens, this side we've got 2 hydrogens. So our hydrogens are balancing, but our oxygens are not balancing. Then step 3, try to make the atoms on either side of the arrow equal by adding more molecules to the side where you do not have enough. That's straightforward. Where there's not enough, you add that side, and then you count again. But again, remember on the right, it's a compound. So whatever coefficient you add must make sure that it actually aligns with whatever is on the right. Let me show you. Remember that our hydrogens are balancing here. Write down the formula of each reactant and each product. So now, remember that hydrogens are 2 this side and this side are 2. Oxygens are 2 this side and this side is 1 oxygen. Remember that this is now a compound. So whatever coefficient you're going to put will add both things. Will add both elements here. That's why we put 2 here to say, okay, now we're going to have 4 molecules of hydrogen and 2 of oxygen. Go to the right. We've got 2, and then now that means our oxygens are balancing, but our hydrogens are not balancing. And then now we say, okay, we're going to be short of 2. We put that coefficient 2 there, and then we are good to go. Our equation is balanced. Let us look at this. Let us balance some equations together, grade 9s. Can you balance this? Who wants to work with me? Raise up your hand. I'll tell my producer to unlock you. Who wants to work with me going through these ones? You will tell me what to type, and then we're doing it together. Producer, do we have anyone who wants to work with me? The only way you can learn is by doing, grade 9s. So anyone who wants to do with me? Do I have someone who wants to do with me?
Yes, there's Nkosi, and Waruna had also opened their mic, but Nkosi is ready.
Nkosi, let's go. Nkosi? Nkosi? Waruna? Who is ready? Okay, I want you to take me through this like this. We've got magnesium reacting with, reacts with oxygen. So magnesium reacts with oxygen to give us, this is what I want you to take me through, to give us magnesium oxide. So this is a discrete. Do we have Gosipek?
No.
Who wants to work with me? So this is how I said to you, magnesium reacts with oxygen. So now we're getting, oh, we have to change it to what you call, I said to you, we change it to symbols first. Okay, from the periodic table, magnesium is Mg, and then oxygen is O2 because it's a diatomic molecule. But then now we're getting the product is magnesium oxide. Then now if we're looking at this, our magnesiums are balancing, but our oxygens are not balancing. So that means we're going to need a coefficient 2 here. And then now we've got 2 magnesiums and 2 oxygens. 2 oxygens, our magnesiums are not balancing. So we're gonna, how many do we have on the right? We've got 2. So we can put 2 here. And then our what you call, our equation is balancing. Who wants to do it, make grade 9s? Do I have anyone there?
Yes.
Yes. Tell me what to write for when ion reacts with oxygen.
Fe.
Fe reacts with
O2 oxygen.
O2 oxygen. What do we
Which
get?
will give us FeO.
It's going to be FeO, which is ion. Which is ion oxide. Angit?
Yes.
It's ion oxide. Remember that when a metal reacts with, when a non-metal or a metal reacts with, we get a non-metal oxide or a metal oxide. Is our equation balanced, boy?
No, sir.
So how do we balance it now?
We need to put a 2 in front of Fe.
Which side? We must always start on the right, ne?
Yes, sir.
So we're gonna put a 2 here because we've got two oxygens on the left. So we've got 1 this side. So we want to balance our oxygens with the ones on the right, on the left. So we say 2. So we've got how many? How many
We have
ions do we have on the right?
2,
How many oxygens do we have on the right?
2.
And then on the left, how many
We
oxygens do we
have
have?
2,
How many ions?
1,
So we're gonna now add, put
Two.
which coefficient we're gonna put in front of ion?
2.
2. Then we can conclude that our equation is balanced. Don't go anywhere. Let us do this one as well. So we've got copper reacts with oxygen. What must I write?
Sir,
We've got copper Cu reacts with O.
O2.
What do we get?
It will give us CuO, which
Which is
copper. Not sure, sir.
copper oxide.
Copper
Oxide.
oxide.
Yes, it's a copper oxide, but our equation is not balanced. Remember that you need to balance it all the time. Let us
No.
work on it. How many oxygens do we have on the left?
2,
On the left, 2, yes.
Oh.
On the right,
1,
so what do we need to do? Coefficient,
2 in front of CuO.
and then we've got now 2 copper and 2 oxygen, and then we've got 2 and 1. So we're gonna put a coefficient.
2 on the left.
Then we can conclude and say our equation is
Balanced.
Thank you very much. You're gonna get a winner when you go back. We've got Hloni. Where's Hloni? Can I have Hloni? Thank you so much, boy. There's
Yes, sir.
Hloni.
So
Hloni.
I see that the equations are balanced. But
Thank you so much.
why
Yeah.
why does oxygen always have a 2?
Because it is a diatomic molecule. Remember, I was explaining diatomic molecules. Let me,
Oh.
don't go anywhere. Let me go back to my slides. I want you to know. Is this Hloni?
Yes, sir.
Okay, Hloni, there we go. So diatomic molecules are molecules of only 2 atoms, and the diatomic elements, so the diatomic elements, we've got 7 of them. 1, 2, 3, 4, 5, 6, 7. I gave you this
Yes.
write down this sentence: have no fear of ice cold beer. So that will be your nitrogen, hydrogen, nitrogen, fluorine, oxygen, iodine, carbon, and bromine. They always represented in this manner. You see where I shaded with red, right?
Yes, sir.
They
Now I see.
always are written in this manner because they are diatomic molecules. They have only 2 atoms in them, and they are represented in that manner. Are we clear?
Okay. Yes, we are clear, sir.
Yes, but don't go anywhere. I want to work with you. I want us to balance these other equations. I was working with Nkosi just now, so it's your chance as well. Here we only have 3. We only have 3 equations that we need to balance. Are you good with
Yes, sir.
balancing, Hloni?
No, sir, I'm not good at all. But I'll
Okay,
give it a try.
Okay, let us work with number 1 first. We've got sodium reacting with chlorine. Remember, I told you chlorine is always represented as Cl2 because it is a
Diatomic.
diatomic molecule. Very good, Hloni. So now I'm saying to you, our product is sodium chloride. Sodium chloride, I wanna the salt that you use for your fries or for cooking at home. This is
Yes,
it,
sir.
sodium chloride. That's type of salt that we get when sodium is reacting with chlorine. But now,
sir.
my question, Hloni, is this equation balanced?
No, it is not.
So let us look at chlorine. How many
Yes.
chlorines do we have on the right?
On the right, we have 1.
On the left?
We have 2.
So that already tells us that the coefficient we're gonna put on the right is
A2.
A2. Then, but
Yes, sir.
do we is it balanced now, Hloni?
It doesn't look balanced, sir.
It's not balanced now because on the right we've got 2 sodiums, and on the left we've got how many? 1.
We got 1.
So we're gonna put which coefficient here?
We're gonna put a 2.
Then our
Balance
our equation is balanced now. We've got 2 sodiums on the left and 2 sodiums on the right. 2 chlorine on the left and 2 chlorine on the right.
Right. Yes.
Then we've got nitrogen, which is a diatomic molecule, reacting with
Yes.
hydrogen, which is also a diatomic molecule, and then it's giving us NH3, which is ammonia. Handy. You see handy that you use to clean your stoves and cupboards? Yes, that
Yes,
is it,
sir.
ammonia. But is it balanced now?
No.
Because we've got 1 nitrogen and 3 hydrogens on the left. But on the right, we had 2. So now what's
Yes.
going to happen?
We are going to put a thread
A 3.
or a 2, sir.
Let us calculate how many hydrogens we have here. So we've got 3 and 1.
We have 3.
But
Yes,
our
sir.
nitrogens are enough. There are 2 here. So let's say on the right, we're going to put 2. You see? So let's
Yes, sir.
calculate how many nitrogens do we have on the right? 2.
We have
How
2.
many hydrogens do we have on the left? On the
3.
right? 3.
We have 3.
Then now here, no, they are not 3, they are 6 now. 2 multiplied by this 3, it's going to give us 6.
6.
Do you understand?
Yes, sir.
So, but our nitrogens are balancing, so we can put a coefficient 3 here. 3 by 2.
3 by 2 is 6.
So how many hydrogens do we have on the left now?
We have 6.
How many on the right? 6.
We have 6 now.
You see, we
Yes, sir.
balanced it.
Yes, now I see we balanced it, sir.
Thank you very much. Let us do the last one.
Okay.
And then I'll let you go. I see you are nervous. Don't be nervous. So
Sir.
is this, okay, I want to ask you, is this number 3 balanced?
Number
at it.
3 is not balanced. Sir.
Why
not
is it not
balanced.
balanced?
It's because on the
No. Sir.
Yes.
it looks balanced.
Yes, it is balanced. I wanted to
Oh,
know what
now
are you
I
going
see.
to say? Yes, it is balanced.
It's
We've
just
got-
swapped around.
Yes, obviously, whenever the elements are reacting on the left, they will be swapped around to give us new products on the right.
Oh, yes, sir.
Do you see now?
Now I see.
Thank you very much for helping me out. Enjoy the rest of the day. But before
you, sir.
you log out, please write down this homework.
Okay.
Grade 9s, here is your homework for next week, Monday. It's a lot of it. I will post these slides and then we will actually do corrections next week.
Okay,
Sir,
sir.
Yes?
sir, can you please explain the number 2 you just did with Sony just now? I'm not sure if it's Sony or Nkosi.
Number 2.
Yes, sir.
Okay. I'm trying to find number 2. Number 2, I did it with Clone. So number 2, it's a diatomic molecule, right? We had, let me put it back. Are you there?
Yes, I'm here.
So it was like this. We've got nitrogen reacting with hydrogen to give us NH3, which is ammonia.
Yes, sir.
So now we said it is not balancing. Why is it not balancing? Because on our right, we've got a nitrogen, which is 1, but on the left, we've got 2 nitrogens. On the left, again, we've got 2 hydrogens, but on the left, we have, on the right, we have 3 hydrogens.
Yes, sir.
So now we said we're gonna put a coefficient. So now Hloni said, let us put coefficient 2 here. So now we've got 2 nitrogens and 6 hydrogens. Are you clear?
Sir, how is it
Yes.
6? How is it 6? Do we multiply the 2 by the 3 on the other side?
Yes, we multiply 2 by this subscript 3 here. And then it's gonna be 2 by 3, and then it's 6. And then nitrogen, 2 by nitrogen, we've got 2 nitrogens. And this side, the subscript 2 gives us 2 nitrogens. The subscript 2 gives us 2 hydrogens. But then now we're gonna go see, Hloni said we must put 3 here. And then we say 3 multiplied by subscript 2, it's 6. Then
But
now, yes?
But why don't we write the 6 that we just got by the 3 multiplied by the 2 over there?
it will change the composition of the atom itself if we just write 6 now.
Oh, okay.
Remember that it doesn't lose its state. We can never break down an element. We can only break down the compound, but an element will always be an element. And we said this is a diatomic element. That's why in this equation will be represented by H2.
Okay, sir.
Are we clear?
Yes, sir.
Please write down the homework, grade 9. We have 5 minutes. The homework: balance the following metal oxides. Magnesium burns in air, aluminum burns in air, lead burns in air, potassium burns in air, mercury burns in air. So remember, air is oxygen. So you will say aluminum reacts with oxygen, and so on and so forth. These slides will be posted just now, www.africateamgeeks.co.za. I'm moving on to the next slides, grade 9. Define the following terms: combustion, rusting, corrosion. Combustion, rusting, corrosion. And then please balance these ones. These are nonmetals. When carbon reacts with oxygen, sulfur burns in pure oxygen, nitrogen burns in oxygen. And then we've got nonmetal reacts with what to give us nonmetal oxides. Then the last one is what is a hypothesis. What is a hypothesis, grade 9? I've explained this during one of our lessons. So go check our slides on www.africateamgeeks.co.za, click on natural sciences, and then open the folders there. You will get all the slides. Then you can also get our videos on YouTube. Just say Africa Teen Geeks on YouTube and then search for grade 9 and S. And then we've got sulfur burns in oxygen, S plus O2, you're getting sulfur oxide, which is balanced equation. Then there's rusting.
Sorry, sir. May I ask a question?
Yes.
I want to ask if is it hydrogen nitrate or hydrogen nitride?
Where?
When is in like ammonia?
Ammonia, it's ammonia. But you can say it's nitrate, hydrogen nitrate, because it has what you call it has 3. It's HN3, and it's
Yes.
yeah. So HN3, it's hydrogen nitrate. So, but which is what you call a ammonia gas. It is a gas.
Okay, thank you.
Yes. So please, guys, do the homework. If you've got any questions over the weekend, don't hesitate to actually inbox me or direct message me on Instagram, on Twitter. Mr. Mbata is not going on a long weekend. He is indoors. Stay safe, stay indoors, spend time with your books. When Corona is over, you will be an A student. Thank you very much. We end there today.